So can we be more clever and try to rationalize which layout is a better choice?
Okay, well, one thing we noticed is that the loads in the
pump is the
side were by far and away the biggest, by I think a factor of 2 or 3.
Yes.
So we don't want, I think we want the bearing either side of the pump.
That's right. And then the motor on the side.
Yeah.
I think that's probably a good configuration.
That one I thought would have been a good one. That's the one with from left to right, bearing.
We could have
pump,
one
bearing,
which has
motor.
both the bearings on the side, but there'll be too much bending in the middle.
I thought so, yeah.
But it will be perhaps easier to service.
I think we should look at it from the.
But the life of bearings usually.
It's quite. I think we should look at it from a bearing force.
The forces perspective.
Yeah, and the bending of the shaft perspective.
For the life of the shaft. Yeah.
Or just the sheer size we have to make the thing.
Shall we try this layout?
I suspect so, yeah.
Okay. So these are the bearings.
So the bearing would be at position A.
Position A.
Okay.
So
therefore the pump is 550 millimetres away from A. That's one feasible position. Ignore that.
Can we not? Oh, okay. So this we don't need to have the extra bit coming up.
No.
Yeah, because
the shorter.
we just like my sort of from
Okay, you start from here.
bearing.
This is bearing A, yeah.
Yes.
I'll show you the tape. Put point A first.
So 50.
So
550.
pump is 550.
Yes.
Pump 550.
Yeah. And this bearing is
Turn B, which is
250 away from that.
250 away.
And the motor
And there's a motor.
is 250 away from that.
250. Good. So this is motor.
So in the X direction, what do we have?
Okay.
So we have at the pump in the X direction. We said the pump in the X direction. We actually have. We have what would be the vertical for the pump.
So this. Okay. So
We designated as vertical, of course.
Where's my calculation? You calculating for the forces. Yeah, this one. Yeah, this is for the.
That's for the motor.
Is motor.
Alright.
And
Okay. So we're working at the pump first.
pump is
So what's the vertical for the pump is in the global X direction.
So X direction this time is this way, right?
This should be.
So for the pump,
That's the vertical. As we
say that way it's positive.
actually no, it's negative. So if we look at it, we looked at is it small to large? Yeah. So pulling.
So it's actually
It is that
positive.
way. It is
It's
positive.
positive.
Yeah,
Should be.
it is positive.
It's positive and it's the one. Is this one right? Horizontal.
And that's the
force.
vertical. It's the vertical. That's the horizontal. The horizontal pulling them together. The verticals.
This. Yeah,
Can you
this.
just which direction is the vertical? Which direction is?
That's vertical that way.
Okay.
So we have it
So
like
X
this,
is vertical.
wasn't it? We have it like this actually. Yeah. So this is the angle, theta, and the force is this one.
Yeah.
So at the moment we want this one.
That's the vertical. Should be in there.
Oh yes, you're right. Yeah. Okay. I agree with you. Positive vertical. Yep.
Yeah. So positive.
X direction that way.
Of.
1376.
And at the motor, what did we say we had?
Okay.
With the
Motor
X.
is with the X horizontal. Yeah. Positive. 2139.2. Okay. Okay. Should we draw out the vertical y direction then?
So the dimensions are the
Same
same.
dimension. A, 50, T, 50.
So the motor, we've got that to hand. The motor one is the,
Okay.
we said,
Motor vertical, actually negative. Are we taking
No,
this way?
Depends on which way or...
I think we take upwards positive, or
well, I
No,
think
we-
we're
we-
talking
we-
about
we-
okay,
we-
well,
downwards.
if we want
So it's
downwards,
positive.
so positive,
Yeah. Downwards positive, yeah.
and that's the vertical direction is 270.2.
Mhm.
Okay, the pump
Is actually
It's
the negative. The
yes,
negative direction is the horizontal.
it's
Whether the pump horizontal was in the negative direction.
yes.
Yeah. That's dB. 5.
Five.
Yeah.
210.5.
Mhm.
Okay.
Okay.
So we will have reaction forces at the bearing,
Mhm.
both in x and y direction.
Mhm.
We have to agree that it's downward global.
Just before you start, do you mind if I just stop the tape just to check we've got sufficient left to do this, or I'd rather we started this on a separate tape. So we have to stop it, unless you
I
tell
think
us.
it had 6 minutes.
Can I change the tape?
How is it?
I'm going to change the tape, okay?
Should we at the same time trying to work out how to calculate the
Start it again with a fresh tape. So
Okay.
this is the second tape of the series. Okay, so we're at the work out the bending moments to work out the bearing reaction.
Yes. Okay, so we'll start with the x direction. Okay. That's page 14. Okay, if we give notation to the forces,
Mm-hmm.
reaction force at bearing A in the x direction,
Mhm.
or AX,
Mm-hmm.
or BX. Okay.
Mm-hmm.
Okay, we take moment about A.
Mhm.
Do you think that's
Anti-clockwise,
moment
okay.
A equals to 0, right?
Mm-hmm.
Yeah. Okay, anti-clockwise direction. So we have force at the pump, 1376.7 times distance,
Mhm.
is T, plus RBX times 550 plus 250 plus again, yes, 2139.2 for the motor. Yeah.
No,
that's
this is
fine,
not
yeah.
there.
Okay. Times, and space there.
Mhm.
Yes, 550 plus 250 plus 250
Mm-hmm.
equals to 0.
0.
Yeah?
Mm-hmm.
Okay. Work out RBX. So it's going to be negative. No, it's fine. We can be. Okay. 2139.2 times. That will be 1050
Mm-hmm.
plus 1376.7 times 5t. Okay. Is negative.
Yeah.
Then divide it by
800.
negative 3754.2
Mm-hmm.
Newton. Okay, so it's in there. Yes, yes, reaction force.
Yeah,
so
yeah.
that's fine. Okay, now we need to take the force balance in x direction. Yeah.
Mm-hmm.
Okay, upwards positive RAX plus 1376.7 minus 3754.2 plus 2139.2